Assalamu alaikum guys, welcome back. Okay, so now guys, so we were doing experimental chemistry, the same experimental design. We did till measurement of mass in the previous lecture, and now we're gonna do the measurement of volume. Okay, volume is our fourth quantity, and in fact, this is the last quantity that we're gonna look at in chemistry. Okay, the rest of the quantities, physical quantities, have to be are covered actually in physics, but over here in chemistry we have no more quantities. So now let's get started with volume measurement. I hope you guys know what volume is. Okay, now, volume, the three-dimensional quantity, the SI unit for measuring volume is meter cube. Okay, this is your SI base unit for volume. There are other multiple units for measuring volume, but again, this is your SI base unit, meaning the standard unit. And yes, there are questions on the past papers in which they ask you to identify the SI unit of volume, of time, of mass, and etc. Okay, so now SI unit for volume is meter cube, but cm cube is also a unit, dm cube is also a unit, millimeter cube is also a unit. There are multiple other units as well, such as liters, milliliters, and so on. So now guys, basically what you need to do is you should know the interconversion in between a few of these units for chemistry, but for physics you need to know the interconversion between almost any unit that's out there in the syllabus. So for that I've made videos on prefix conversion in physics. So I'll just put up a card up there on the right hand side of your screen. You would see it hopefully, and on that if you click it, you'll be linked to the O-level physics videos in which I have talked about the interconversion of physics, so of the prefixes basically. So do watch that series as well, that playlist. Actually, I've made just a single playlist of O-level physics concerning mainly with prefix conversion, and that's actually very important, especially if you are in O-levels. So yeah, it's a very good thing to start from in physics actually. Okay, and in fact it is the first chapter of physics as well. Now let's look at a few important interconversions. 1 meter cube is equal to 1000 dm cube. Okay, the decimeter cube, dm cube, 1 meter cube equals 1000 dm cube. And how this came, this derivation of this has been covered in that lecture as well, in the physics prefix conversion. But over here I would just give this statement, and I would just uh, expect you guys to know this. Then 1 dm cube equals 1000 cm cube, and this is in fact the most important conversion, because this is repeatedly asked throughout your O-level chemistry. Okay, 1 dm cube equals 1000 cm cube. Please remember this and do not forget this at any cost. Okay, the first one isn't that important, but the second interconversion is very important, especially when we'll be doing molar calculations. 1 ml equals 1 centimeter cube, and then 1 liter equals 1 decimeter cube. So liter is the same as decimeter cube, dm cube, and ml is the same as cm cube. So if 1 liter is the same as 1 dm cube, and we know that 1 dm cube equals 1000 cm cube, then we also should have no difficulty in figuring this relationship out. Since dm cube is the same thing as liter, so 1 liter is equal to 1000 cm cube, and cm cube is the same thing as ml from this relation. So yeah, this relationship should also be clear in your head by now. Now let's move on. The SI base unit is meter cube. Now instruments for measurements. Okay, now these instruments are very important, and it's very important for you guys to have a good grip on these instruments, because you'll be using them throughout your O-level chemistry, throughout your A-level chemistry, until you reach your desired university. So yeah, this is the basics of chemistry, the instruments basically of a lab related chemistry. And I would really suggest, please pay your due attention over here. Now let's look at them. The very first instrument that we have is a beaker. Okay, you can have beakers of various sizes, various volumes, but over here the very common ones are the 250 cm cube, the 500 cm cube, 1000 cm cube. Okay, these are the common ones which are used in school labs, but you can have many other beakers as well. Okay, and I'll show you a picture of a beaker in just a bit, but let me make this clear that beaker is only used for estimation and is not used for accuracy. Okay, not used for accuracy because it will not give you the accurate volume. If you want to do an experiment and you want to measure out a volume of one chemical and a volume of another chemical, you are not gonna use a beaker for that, because beaker is not for measurement. It's just for mixing stuff, it's just for making solutions, but it's not actually for accurate measurements. For example, if you're doing titration, I know you guys might not know what titration is, but in the basics, but for those of you who know, in titration you need very accurate measurements, so you are not going to use beaker in titration. We are going to talk about titration in detail later on. Okay, so this is used for estimation, and this is how your beaker looks like. Okay, it has a beak like structure over here. It has a beak just like the beak of a crow, so that's why it's called a beaker. And this is a container over here, and this is a 250 ml beaker. Okay, now let's move back to our slide. Okay, now measuring cylinder. This is our second instrument, and measuring cylinder has a greater accuracy as compared to a beaker. Okay, 50 cm cube or 100 cm cube. These are the standards which are used in our syllabus. You'll find questions of measuring cylinders of these volumes. Okay, if the measuring cylinder has been used in any experiment, it will most probably be of any of these two volumes. Okay, and very little chance that you might find a measuring cylinder of some other volume. Okay, and it measures to the nearest centimeter cube. This is an important statement. This is something I would expect you to learn, because again, they do ask you the accuracy or the least count of cylinder, measuring cylinder in ATP especially. Okay, and it is more accurate than a beaker. And of course, it's more accurate because it has all these graduations and all these marks. Okay, and let me show you a diagram of a beaker, of a measuring cylinder, sorry. Okay, this is how your measuring cylinder looks like. Okay, and it also has a beak like structure over here, and it is cylindrical in shape, so that's why it's called a measuring cylinder. Okay, now this was about the measuring cylinder. Now let's move on to the more important ones. Okay, pipette. What is a pipette? Pipette is actually used for measurement of fixed volumes. Okay, fixed volumes, what does this mean? I'll explain in just a bit. You cannot measure something like 22 cm cube or 16 cm cube with a 25 cm cube pipette. Okay, now 25 cm cube, why did I choose 25 cm cube pipette? Because this is the one which we'll be using throughout our O-level chemistry, and also in AS chemistry when you'll have your practical labs. Okay, why 25 cm cube pipette? Because that's the standard. Okay, that's the CIE standard. Now 25 cm cube pipette only has a mark till the 25 cm cube and doesn't have a mark below that. So that means you are either, it's like an all or none situation. Okay, you either are gonna fill the pipette fully or you are not gonna fill it at all. So the pipette can only be filled fully. So that's why you cannot measure something like these, or a volume less than 25 cm cube with a 25 cm cube pipette. Okay, you cannot do that. You have to measure out exact 25 cm cube. If you want to measure something less than 25 cm cube, for instance, if you want to measure 20 cm cube with a pipette, then for that you'll have to use a different pipette which will have a volume of 20 cm cube, and then you'll have to use that. And pipette is used in a very important experiment of titration. Okay, we'll be talking about titration later on, but again, you should for now just learn this and keep it somewhere at the back of your head, that titration is what uses pipette, and pipette is important. Okay, and you'll be hearing this term a lot later on, of course. And let me show you a diagram of pipette if I have any. Okay, wait. Okay, there it is. This is how your pipette looks like. Okay, it has this bulb, not a bulb, but rather this swelling over here of the glass, and a nose type of piece over here, and this is the starting place. You place your mouth over here or a bulb over here at this region, and this is the point which is dipped into the solution. Okay, and if you are asked to draw out a pipette, then of course you have to be careful about this swelling over here. Okay, you have to draw it somewhat like this. You have to show this part to be a bit curved, and then you have to show this bulge over here, and then you have to take it forward. And this is how a pipette looks like in drawing. So you have to be careful about this point. And over here, you might see that it's a 50 cm cube pipette. What does that indicate? Well, 50 cm cube means it can measure up to 50 cm cube. It can only measure 50 cm cube, okay, or 50 ml. I told you that ml is the same thing as cm cube. So this is a particular 50 cm cube pipette, but again, we don't have a 50 cm cube pipette in our syllabus. We'll be having a 25 cm cube pipette, and till now I hope you guys have learned this value, 25 cm cube. Okay, now this stand over here, this stand is called a retort stand. Okay, a retort stand, the brownish color stand over here. And in this stand, this instrument that you can see that is hanging from this stand, this is called a burette. Okay, what is it called? It's called a burette. And this burette, the importance of burette is that it is also used in the same titration experiment. This setup is for titration, by the way. Okay, and in this this burette, the speciality of a burette is that it can measure up to 0.1 centimeter cube. So it can measure a volume less than 1 centimeter cube as well. And by the way, a burette doesn't measure out fixed volumes like the pipette. It can measure out volumes less than 50 cm cube as well. Although the volume of burette in our syllabus is 50 cm cube that we have. Okay, burette is 50 cm cube, and pipette that we use as a standard is 25 cm cube. Okay, but burette can measure volumes less than 50 cm cube, but pipette cannot measure volumes less than 25 cm cube. It only has to measure 25 cm cube, and that's it. It cannot measure. If you have a 25 cm cube pipette, you cannot measure something like 20 cm cube with that same pipette. Okay, now let me go back to a few points that we have. Okay, let's go through these important points about burette. Burette measures to the nearest 0.1 centimeter cube, but you have to record the readings to 2 decimal places. 50 cm cube is a standard volume burette used. Okay, what do I mean by this point over here? You have to record your readings up to 2 decimal places. 2 decimal places means that if you take out a measurement with a burette, and let's say let's say it's 46 cm cube of volume in that particular burette, and you pour out 46 cm cube of volume from a burette, what does that mean? How are you going to record that in a table in your chemistry syllabus, or in a scientific way? How are you going to write it down? You have to write it down to 2 decimal places. If it is exactly 46, you have to write it down. You have to record it as 46.00 centimeter cube. And why am I stressing on this so much? Because this is a very, very integral part of your ATP paper. Okay, ATP paper, the titration experiments in ATP, all of them have, in all of them, you have to record your readings to 2 decimal places. And by the way, not just ATP, but also the practical papers of AS, of A levels, also would require you to record your readings up to 2 decimal places. Okay, so now this is an important term, again, important point to remember. Okay, you have to record your readings up to 2 decimal places for your ATP exams or for your practical exam, because that's a scientific way, scientific convention. Okay, and by the way, burette can measure out to the nearest 0.1 centimeter cube. Okay, so you can have a value such as 46.50 centimeter cube, or you can have a value such as 46.30 centimeter cube. Okay, you can have values in between 46 and 47, because it can measure less than 1 centimeter cube as well. Now let's move on to the I've shown you a burette. Okay, this is how a burette looks like. It's a big it's a very long instrument. Okay, and you have to hang it with a retort stand right over here, and then you have to put a conical flask beneath it. Okay, this is how a conical flask looks like. It's conical in shape, that's why it's called conical flask. It's a cone like flask in shape. Okay, and its edges are round, and this is how it looks like. Roughly, this is how it looks like. Okay, and again, this is this conical flask is not used for accurate measurements. It's just used for mixing and making solutions. It's not used for measurements, okay, because it has a very low accuracy. Then after the conical flask, and you can have various different volumes of conical flasks, okay, and that's not actually very important. You don't need to learn these. They won't ask you the volumes of a conical flask, but it's better to know these two standards, okay, because these are the ones which I have seen throughout your past papers. Now moving on to the sixth instrument, volumetric flask, which is used for making dilutions. Okay, now what does dilution mean? Dilution means you take a concentrated solution and you add distilled water to it, and you change its concentration. Okay, what would happen if I add distilled water to a concentrated solution? For instance, if I have okay, let's not go into the concentration units, etc., but I just tell you that let's say I have a glass full of water, and in that glass I put let's say 5 spoons of salt, 5 spoons of sodium chloride. It gains a particular concentration, and later on during this course you'll find out that concentration also has a unit of mole per dm cube. This is a unit of concentration, but never mind, you don't need to worry about the units right now. Okay, just remember that you have a flask or a glass in which water is filled, and you have 5 spoons of sodium chloride or salt in it, and you have another glass with the same volume of water, and you add 2 spoons of sodium chloride to it. So which one will have a greater concentration? It's the 5 spoons one. Okay, it will have a greater concentration compared to the 2 spoons one. Okay, so that's why I would say that that's more concentrated. Concentrated means that's how much solute is present per unit volume of the solvent. That's the amount of solute which is present in a particular solvent will give you the concentration of that particular solution. Okay, so since there is more solute in here and less solute in here, that's why the concentration of this 5 spoon cup is going to be more as compared to the 2 spoon cup. So now if you want to change the concentration of the 5 spoon cup to the 2 spoon cup, how are you going to do that? Well, there are two ways of doing that. Either you remove the solute from it, but if the solute has dissolved, then you cannot remove it by just pouring it out. There are other other physical techniques or purification techniques which you can use, but you cannot just remove it out easily, right? You cannot remove out the solute. So the second way of changing the concentration is by adding in more water. Okay, when you add in more water, when you add in more solvent, then that means the ratio of solute to solvent now changes. And now the ratio of solute to solvent decreases. And since this ratio decreases, that means again the concentration now decreases. So just to sum it up over here from this point, what the takeaway point is that the volumetric flask, you have to remember its name for making dilutions. Okay, and again, this is an important point with respect to your ATP paper. Okay, and I've seen this question being asked multiple times as to which apparatus is going to be used for making the following dilution, and the answer to that is volumetric flask. Okay, and let me show you a diagram of that. This is how a volumetric flask looks like. See, it's a pretty bowl and with a fixed mark over here. See, you can see the mark over here. And now you have to always fill it up till this point, okay, with distilled water. Okay, you add in the solution and stuff, and then you have fill it till this point, and you get a particular concentration or dilution over here. Okay, and the volume of this volumetric flask is 250 ml or 250 cm cube, and you have to remember that. Okay, 250 ml is the standard volumetric flask volume that we use in our lab conditions. So it's a value that you need to learn. This is also a value you need to learn. Now let's move on to the last the last one, gas syringe. Okay, what is the gas syringe used for? Gas syringe is, if you are asked, okay, gas syringe is also a very important apparatus because it also has a lot of questions on the past papers. And the gas syringe, well, there are mostly questions on gas, on to identify the apparatus that is used to collect the following gas that is being produced in the particular experiment. So the answer to that is going to be gas syringe, and there has been questions regarding gas syringe so many times on the past papers as well. So you need to remember what a gas syringe is used for, and of course it's easy. The name suggests Gas syringe means it's a gas collection syringe, but it doesn't only collect gas, but it can also measure gas up to 1 cm, 100 cm cube. Okay, 100 cm cube is the volume, and that's the volume of the gas that is produced. It can be measured as well. Okay, and let me show you how it looks like. Okay, this is how a gas syringe looks like, and a particular 100 cm cube gas syringe, and this is how you connect it. And by the way, this diagram again is important. Reason why it's important, it's not because of the labeling, it's not because of this labeling that is important, it's because of this diagram, the connection of the gas syringe with this conical flask. You have been asked on your exams to draw out this diagram. Okay, if you look up the past papers, you will find out questions in which, even in the theory questions, you have been asked to draw out this diagram. So you should know how to draw out this diagram. Just okay, the important point to note over here is that if you look at this, the mouth of the conical flask, there is a cork over here. See this cork? This cork is for prevention of uh, to prevent the gas from leaking out or from escaping out, right? And this delivery tube is over here so that no gas goes out and all the gas goes into the gas syringe. So this is simple. You just draw in the conical flask, you just draw in the delivery tube, but remember, make sure to draw in the cork. The cork is important, and make sure that this tube is connected and it is above the level of the solvent. This is important. This was another point written in the marking scheme, that the tube must be above the level of the solvent. Okay, must be above the level of the solvent, because some students have drawn it by dipping it into the solvent, and that's wrong. They've lost that mark over here. And that's it. That's how you are going to draw it out. And you don't need to make a fancy syringe over here. You just need to draw in a simple syringe over here. They're not testing your drawing, they're actually testing your concepts, and that's how they are going to test you. And this okay, now this is another important part, how to read the correct volume measurement, and I think I'll cover that in the next lecture. Okay, thank you so much for being patient.